So I think our next and last speaker of the morning is Dr. John Patience from Iowa State University. I've had the pleasure to work with Dr. Patience through my professional career in the allied industry and producers looking at different ways to improve efficiency of our swine production. The most, recognized grant I think Dr. Patience done for the industry was the NEFA grant that he looked at feed efficiency and put on some very nice seminars or meetings for both industry and research looking at feed efficiency. So we talked earlier this morning about how to bring the industry back into the story in discussions, and I think, in Dr. Patience's career, stemming from the University of Guelph and now at Iowa State, he's done a really great job of working with the producers, allied industry, and academia to help bring more sustainable production to our swine industry. And please, let's give a welcome to Dr. John Patience.
Well, thank you very much. It's a real honor for me to be here. Dawn, thanks so much for inviting me. This is not the kind of conference that I typically get to speak at, and so I'm finding it fascinating. I'm seeing how different scientists are approaching the same problem from completely different directions. And to me, that's the essence of science. That's the imagination and innovation that individuals bring to the process, and that's hugely valuable. I also appreciate the invitation, the opportunity to be here, because it's caused me to take a look at the world I live in, swine nutrition, and specifically applied swine nutrition, and try to integrate it better into more of a total picture, in this case related to sustainability. And oftentimes we're much more worried about what the lysine requirement is, the response to energy, whether this vitamin is deficient, and whether we really understand essential fatty acids or not. So I really am looking forward to giving this presentation today. I really had a lot of fun putting it together. So this is one of the models that is often used to portray sustainability and the need to address social, environmental, and economic sustainability in order to put the whole package together. So, and I use this model not because I particularly liked it, but it's within my very limited artistic capabilities in PowerPoint. So I adopted it to pork production and nutrition. And so in terms of environmental sustainability, I'm going to talk about water and soil. I'm not going to talk about air, primarily in the interest of time. Under the side of social sustainability, I'm going to talk about health and welfare of pigs. And then on the economic side, I'm going to talk about economic efficiency of the individual farming unit as opposed to the broader economics of the pig industry or communities, although I think that's really, really important. So I'm going to start with water and soil and give examples of, Professor Godfrey, you said you were giving some, overview, and you apologized. I don't know for the life of me why you apologized, but that you were, just covering the surface of some topics. Well, I'm going to be even more so, and I'm going to jump around quite a bit. But as we talk about water and soil, first I want to talk about water, and you brought it up, Professor Godfrey, in your talk about the competition, the limitation of water, our water resources, and the competition that is already starting, but is going to become increasingly important in terms of water availability for agriculture relative to water being needed by human populations. And that's only going to get worse. So let's take a look at water. And if we take a look at a pig, a 45 kilogram pig growing around 785 grams a day, eating 2 kilograms of feed, and the feed conversion of 2.54, that pig will have a total daily water intake of around 5,600 grams per day. 4,500 of that is drinking water. So first off, is by no means is all the water that a pig has at its disposal strictly drinking water. That indeed 15% of the water that pig has available comes from metabolism. And then there's a small amount of water comes from the feed. And much of that water is excreted through the urine, but a substantial portion is lost through respiration. And that poses problems for us in terms of ventilating barns, but it's important for us to keep in mind. And really only a very small percentage of the water consumed or made available is actually retained in the body of the pig for growth. So we can, as nutritionists, we can kind of screw this up if we're not careful and understand that excess protein and excess minerals will increase the demand that the pig has for water. And as this study from Marnie Shaw in her master's program shows, excess protein is much more of a concern than excess minerals, and that runs counter to most people's thinking, because we think, oh, you feed too much salt, the pig's going to drink a lot more water. We don't think about excess protein. And I'm going to talk about lowering protein in diets later on. But when Marnie increased protein from 18 to 21% and then to 25%, water intake, and by the way, this is water intake, not disappearance, and there's a big difference when you're studying water. So we're studying actual water intake, increases very substantially. Obviously, there's more water lost in the feces, more water lost in the urine, but looking at the amount of water retained by the pig really didn't change that much. But we sure wasted a bunch of water in the process. And another example is how we deliver the water. So now I'm stepping away from being a nutritionist to being a management guy, and realistically you can't separate the two. But the flow rates that we use for delivering water to the pig via a nipple drinker, and our recommendation for growing finishing pig would be somewhere around 500 mils per minute. But there's many books out there that would tell you 750 mils to a liter per minute is required. And we can see that as we increase the flow rate, now this is water disappearance, not intake. Water disappearance increases in pretty much a linear fashion. Feed intake increases to a point and then plateaus, meaning that at this point, that pig is consuming enough water in order to meet its water requirements to maximize intake. And of course, if we don't drink enough water, we're not going to eat enough feed. Daily gain increased according to feed intake, of course. We look at the water to feed ratio. The water to feed ratio actually, and that's the best way for us to understand the water requirement of the pig, is really about 2.5 to 1. 2.3 to 1 maybe in a finishing pig, but it's about 2.5 to 1. So we can take a look on the next slide and look at the amount of water that's being wasted. So at 700 mils per minute, which is below what some people would recommend as the requirement for the delivery of water, almost half the water that is flowing through the nipple drinker is being wasted. Excuse me. So if we compare different ways of delivering water to the pig, we can see that the wet-dry feeder is much more efficient than a dry feeder using nipple drinkers, reduces water disappearance by 25%. If we use a swinging nipple drinker that hangs from the ceiling rather than attached to the wall, we can reduce wastage by about 11%. And a drinking bowl versus a swinging nipple drinker, we can reduce water wastage by 25%. These are important numbers because they're dealing with a resource that's going to become increasingly limiting in our industry in the future. But also we have this understanding, now I'm going to the other side about not so much delivering too much water to the pig, but now not delivering enough. And in this case, this is some data on sows from Dave Fraser, who did just some wonderful work. And this is really, really difficult and expensive work to do, technologically very demanding. And what Dave shows is this relationship in the newly farrowed sow between the sow's water intake and the growth of her litter. And we can see that as her intake goes down, the growth of her litter declines as well. Now, this is a relationship. We don't know if she's drinking less water and therefore producing less milk, or she's producing less milk and therefore drinking less water. We don't understand cause and effect here, but we do know that relationship exists. And even later on in the second week of lactation, the slower growing pigs are nursing sows that are drinking in the lower 50th percentile of water intake. We need to understand water consumption in the sow much better, particularly, I'm going to show you some data later on sow productivity, and we just can't afford to have sows not drinking enough water. That's going to cause problems. Just a couple of other points. One is the use of synthetic amino acids. We take that for granted, and yet this was a tremendous technological development for our industry and the poultry industry, because we can reduce the crude protein content of diets far more than we ever imagined possible. And so with synthetic amino acids, we can comfortably lower crude protein levels by 3 to 4 percentage points. Oops. And every percentage point that we lower crude protein, we can lower the nitrogen content of manure by 4 to 5 percentage points, or 4 to 5%, excuse me. And that's substantial when it comes to the sustainability of manure application and the quantity of land that's required to sustainably apply manure to the land. Synthetic amino acids also have reduced our demand on soybean meal. And this is actually the number that I find more fascinating. Mike Tokash developed it. And back in 2010, and we're using more synthetic amino acids today than we did a decade ago, because we now have tryptophan much more inexpensively, and now isoleucine's coming along. But he calculated that the pig industry in the United States is using about 14 to 15% less land for soybean meal than had we not had synthetic amino acids at all. That's a profound change in the demand that we place on our farming capabilities just due to one technology. So in our earlier presentations and talks about technology, this is an example of technology having a profound impact. Phytase is one of those technologies that it's really nice for nutritionists to work with because it always works. I don't know if I can't say this about any other experiment I've ever done, but I can't remember doing an experiment with phytase that didn't work. And this is a study. Pardon me. Am I hitting the? There we go. This was done by Kristen Olson in her master's, and she was feeding diets that were adequate in phosphorus and then adding phytase to those diets. And you can see that she was still increasing the amount of phosphorus that was being retained by these pigs by adding up to somewhere in the range of 400 to 600 FTUs of phytase to that basal diet that already was supposedly adequate for the pig. Denise Bolio did some work about a decade ago, or more than a decade ago now, and showing also that by adding significant amounts of phytase, she was kind of one of the early people doing work on superdosing, that she could dramatically reduce fecal output of phosphorus, and she could improve the balance of phosphorus in these pigs, and interestingly, reduce the proportion of phosphorus that was being excreted by the pig in the terms of the soluble organic component, which at least theoretically is that form of phosphorus which is more likely to leach and therefore be of greater environmental concern. Okay, so that's the water and soil story, and I'm keeping a close watch on the clock because I'm the one thing standing between you and lunch, and that's only assuming if you're polite and don't get up and go to lunch before I'm done. So I will continue on, and now we'll move into health and welfare. The environment story, I don't think that's a novel story. We know that as nutritionists, we have a responsibility and a capability to influence the environmental impact of our industry. But what about health and welfare? Well, first off, how important is health? And this is a study that Alyssa Cornelson did as part of her master's degree. And this was done in commercial research facilities, so about 1,000 head barns each. Tremendous effort on her part. These barns were maybe 50 feet apart from each other, so they were in very close proximity. And yet she maintained a low, medium, and high health challenge in these barns for the full grow-out period. She literally did just about live in those barns for the full grow-out period. The low challenge pigs, they had PRRS, but they didn't have many other diseases, so the impact of PRRS was not that great, so mortality was in the range of about 3%. The medium challenge pigs, they had a more virulent strain of PRRS and were affected much more, and they had a mortality in that barn of about 8%, if I remember correctly. And then the high health challenge was the pigs just were exposed to a lot. They had a virulent PRRS, they had swine flu, they had mycoplasma pneumonia, so they were very unhappy pigs, and they had mortality of about 19%. So nicely for Alyssa is this experiment embraced pretty much the full range of mortality that we would see in commercial practice, but under commercial practice, for those not aware, 8% would be considered quite high, and 3% would be kind of in the normal range. But we can see, first off, I just point out, we fed the pigs to a constant end body weight. So, you know, you can do an experiment two different ways, feed to a constant body weight or feed to a constant time. We fed to constant body weight. You can see that disease increased the variability of the body weight of the pigs, which has a significant economic impact on our producers. It had a dramatic effect on average daily gain and feed intake, not surprising, but somewhat surprisingly, did not have that big an impact on feed efficiency. At least I was personally surprised by that. And on a carcass basis, and we do a lot of our work now looking at performance on a carcass basis as well as a live basis, because our producers sell their pigs as carcasses, and that information is more directly relevant to their circumstance, and the results were the same. Let's take a look at the economics. With the mortality, of course, there was less weight to sell on the pigs that were less healthy. So that reduced revenue, but it also reduced cost because there's fewer pigs to feed, and therefore we spend less money on expenses. But take a look at the net profit. We had a swing, and this is modeled to a 2,400 head wean to finish barn, which is kind of our typical barn in the pig industry. And so we had a swing in the low health challenge pigs of a profit around $34,000 to the pigs in the high health challenge, a loss of $16,000. So that swing is almost $50,000. That is a massive amount of money and illustrates the huge impact that disease has on the economic viability of the sector. And even with the medium health challenge, the swing was $28,000. So that's quite substantial. So health is a big deal, and we have to pay attention to it. And I guess many of you in this audience already know the biggest show for the pig industry on an annual basis in this country is World Pork Expo, and they've canceled it this year. They just announced that today. Yeah, sorry, Merlin, I should have told you the break. They've canceled. 20,000 people come to Des Moines, Iowa, and they've canceled it because they're afraid of all the international speakers potentially bringing African swine fever into the U.S. So there's a lot of fear out there. That's a tremendous move. But here's a study that Nicole Huntley did just to look at a little more basic level, looking at the impact of immune system stimulation and on maintenance energy requirement. Thanks for introducing the subject of maintenance. And you can see here, tremendous increase. This was done in by indirect calorimetry, increase in heat production, but of greatest interest to us was about a 25% increase in the maintenance energy requirement of these pigs experiencing immune system stimulation using the LPS model. And in a sort of the daily intake of a pig, something in the range of about 30%, 28 to 30% of the energy the pig consumes is going to go to maintenance. We increase that by 25%. That is big time. That is a major issue. So what can we do about health? Well, amazingly, we can look at enzymes. I should have been talking about enzymes when I'm talking about efficiency and utilizing nutrients better, but I want to talk about enzymes and how they affect animal health. Our mode of action of enzymes, we're thinking that it improves fiber and therefore nutrient digestibility. We're thinking that that somehow we can run study after study and pretty much consistently get an improvement in in digestibility, but we don't always get an improvement in growth performance. And that's very puzzling, and it's very frustrating. I wish carbohydrates were like phytase, because then we would always get the response we're looking for, but they aren't. And so we need to better understand the mechanism, because carbohydrates is one of those technologies that gives us the ability as a pig industry to utilize higher fiber ingredients more effectively. So putatively and very simplistically, we can suggest then that the mode of action of a carbohydrase enzyme in order to give us an improvement in growth performance is we want to improve nutrient digestibility, which could, and it doesn't take too much imagination to suggest we get an improvement or we get a prebiotic effect because we get the release of some components of the diet that might be stimulatory to the microbiome in the lower gut. Therefore, an improvement in gut function and a reduction in immune system activation. We now have data which has not been generated in the most controlled fashion, but it's so dang consistent that we pretty much have to accept that the carbohydrase enzyme is reducing mortality in wean to finished pigs. And unfortunately, you have to run a very, very large study in order to measure mortality of this magnitude, reducing mortality by perhaps 1 percentage point. Well, that's very economically viable given the relatively small cost of the carbohydrase enzyme. But it shows that something is going on with these enzymes, which is way more than just improving digestibility. So here's a study that Qingyun Li completed for her dissertation, and she compared a carbohydrase enzyme without and with, and an enzyme blend without and with. And the enzyme blend had xylanase in it, but also had a protease and one other enzyme present. And she got an improvement in average daily gain. This is a nursery study and was not a challenge study. But she did not see any difference in average daily feed. So far, so good for our model. But what she found, which was really interesting, is that in this same group of pigs, when she looked at one measure of gut barrier function, the lactulose-mannitol ratio, those pigs that grew faster also showed, on a treatment comparison basis, an improvement in gut barrier function. And those pigs that were just on the xylanase treatment and did not show an improvement in average daily gain did not show this improvement in gut barrier function. She measured, and I'm just showing a few bits of her data, looking at some of the genes that were coding for certain components of gut function. In this case, it was Clodin 3. And again, the pigs that showed an improvement in average daily gain, there was an increase in at least the message for Clodin 3. We did not measure protein, but at least the message was increased. And interestingly, there was a decrease in the message for IL-22, which is associated with the innate immune response. So far, we can start to see what might be a picture of what this carbohydrase enzyme is doing relative to animal health until we went too far and we measured too many things, and we thought that we should see an increase in the lactobacillus species in the microbiome. And Qingyun looked in both the cecum and in the colon, and lo and behold, they went the wrong way. Or at least they didn't go the way we expected them to. And I shouldn't really say the wrong way. It just didn't fit our understanding or our expectation, and therefore we need to change our understanding and expectation. So obviously this experiment doesn't prove what the xylanase enzyme is doing, but at least it was an interesting experimental model, and we need a whole lot more data to give us a better understanding. Is this enzyme in actual fact, or enzyme blends in actual fact, giving us the potential for improved animal health? Now, obviously, I think probably everybody in this room understands that there's a great deal of pressure on our use of antibiotics, and we need to use fewer antibiotics in our industry and are already doing so. And here's a study by Lee Ruckman, and she ran the study. This was on about a 1,300 head commercial barn, and again, they had a significant health challenge. And so she ran the study. The red is without antibiotics, and the blue bars are with antibiotics. And so when in the treatments where antibiotics were present, adding spray-dried plasma protein or dried egg protein and that dried egg protein was produced from hyperimmunized hens, there was no benefit. But when she ran the treatments in pigs without antibiotics, there was a very significant improvement in the performance of those animals receiving spray-dried plasma and dried egg protein. And interestingly, there was really no difference then between the animals that had received antibiotics and no additives and the pigs that didn't receive antibiotics but were receiving the additives. Now, we don't expect that all the time. One of the challenges of using these kind of additives is they tend to be very situation specific. Antibiotics tend to be much more universally applicable. And when we're dealing with products like this, they tend to be much more situation specific. But it points to what I believe is a big, big change going on in swine nutrition, and I suspect in all nutrition, certainly in human nutrition as well. And that is, we need to look at ingredients more than just as sources of energy and nutrients. That individual ingredients bring specific functional properties to the party and will have different effects on the gut of the pig. So for example, we do know that if you put in a highly insoluble fiber in the pig's diet, grow finish pigs, they tend to be more susceptible to swine dysentery. If you put a highly soluble fiber in the diet of a newly weaned pig, they tend to be less susceptible to an E. coli challenge. And so as our use of antibiotics goes down, and as the market for pigs that have not received antibiotics at all in their lifetime increases, this whole aspect of functional properties of ingredients is going to become more and more important in swine nutrition. Turning more on to the welfare side, this was a study done in the Netherlands showing that in sows, in gestating sows, putting fiber into the diet did not reduce their feeding motivation, which is a concern that some people have expressed. It did reduce their exploitative behavior, meaning less stereotypies and so on. It reduced their drinking behavior. I'm not quite sure I understand that one. And it lowered circulating levels of ghrelin, suggesting that it might have had some impact on the appetite stimulation. Interestingly, straw bedding, which of course those sows would eat, did not have the same effects as adding the fiber to the diet. That's the big take-home message for me in this study. This is another study done in Denmark. It was done on a commercial farm, so a large-scale commercial farm, 300 sows per treatment. I'm really impressed with the sow research coming out of Denmark right now. They're doing great work. They're doing it on commercial farms, so it helps to ensure the relevance. And look at the productivity that they are under which they're doing these studies. So they had 18 pigs total born in these sows under study, and the number born alive was just under 17 pigs per litter, which is just phenomenal. And but interestingly, when they fed fiber from day 102 of gestation through to weaning, they got a reduction in the proportion of pigs that were stillborn. They got a reduction in the total mortality, so that's stillborn plus pre-weaning mortality. And they got a reduction in the number of pigs that died due to poor viability at birth, and a reduction in the proportion of pigs that died from diarrhea, just by adding relatively common sources of fiber to the sow's diet starting late in gestation. We're going to see a lot more of this, just absolutely. Another Danish researcher, Peter Thiel, has shown that by just how you feed the sow prior to farrowing, he can reduce stillbirths in at least one experiment by 50%. It's fascinating work, and there's not a lot of work going, we need a lot more work on the modern sow. So turning now finally to economic efficiency, as my time is up. In this particular case, we want to show the response to dietary energy. As we reduce energy, the pig will increase feed intake to the point of the capacity of their gut, and then they won't eat any more, and we run the risk of feed intake going down. We didn't see it here, but we also will get worse feed efficiency. The one truism we know in swine nutrition, increase energy and you get better feed conversion. If you don't, you screwed up. That's just pretty much guaranteed. But let's take a look at the economics of this. This is a study that Brett Frederick and Paul Klein did at Christensen Farms in their research facility. They took a standard corn soy diet, added amounts of bran to the diet to lower the net energy content of the diet. They lowered the feed cost by so doing this, but they wanted to look at the overall economics. And what they found is that when they lowered energy, even by 50 kilocalories, which isn't very much, they got a reduction in growth rate. So therefore they had, 1.8, for example, kilograms of gain to make up for. That would take 2.8 more days in the barn to make that up. Those 2.8 days would cost 39 cents on yardage cost. That extra feed to produce that extra 1.8 kilograms cost $2.40. So instead of reducing their cost, it actually increased their cost of feed. I could have shown an awful lot of examples of this, but the fact of the matter is, and this is as old as nutrition is, that's something we've always focused on, and that is working with individual producers to try to improve the financial viability of that particular farming operation. And there's lots of examples. So in summary, from an environmental point of view, nutritionists can participate or be involved in contributing to conservation of water. They can help to reduce nitrogen and phosphorus content of the manure. We've known that for a long time. We can reduce the amount of land that's required to produce the feed that we need to feed our pigs by improving efficiency. We can improve animal health. We can improve animal welfare. And we can help in the development of alternatives to antibiotics to help us and our industry move in that direction. And obviously, we have a particularly important role to play in optimizing diets to improve the financial viability of individual farms. This is my crew. We took them to DPP in Brisbane, Australia, so they were all in great moods. They were all dressed up. They were smiling for the camera and completely ignoring the fact that their wine glasses are empty and the only thing put in front of them was a dinner roll. But anyhow, thank you very much. I really appreciated this chance.
We still have time for some questions for Dr. Patience.
One question on the fiber for the sows. What type of fiber was it? Because I was under the impression that if you increase fiber, you have a drainage issue in the confinement barns.
Very good, yeah. So very good question, very practical question, right? So they used 3 different fiber sources. And so they used dehulled sunflower meal, they used soybean hulls, and they used, I believe the third was beef pulp. Beef pulp's a little more economical there than it is here. And the problem of drainage is not so bad if we don't overdo it. But if we use bedding, then we really do have a problem. And as long as, in this case, I would think that the fiber levels that they were using, and for the length of time they were using it, that as long as there was sufficient moisture level in the manure, that would not have been a problem. And then of course that fiber then goes out as organic matter in the manure. Yeah. But good question. Yeah.
Clint?
Really nice talk, John. Appreciate that. Really like your summary. Wish I would have followed the same approach here. On the carbohydrates issue, has anybody used an ileal cannula model to look at the digestibility? And then I'm wondering also then with your small intestinal changes and structural integrity, if anyone has actually looked at the transporters, because I'm wondering if there's some offset there with the fiber as to where you're seeing the increases in digestibility, i.e. if that's all hindgut, maybe you're not capturing those calories anyhow.
You bet. Great. Thank you for the question, Clint. I took those slides out because knew I was going to run out of time, but we actually just finished a study now we're in the lab where we put in 2 cannulas. We put in one mid-jejunum and one terminal ileum to look at the progress of digestion, and that's with and without Xylanase, to look at the progress of digestion, but also the appearance of the breakdown products of digestion and whether that's having an impact on the microbiome. Sorry, we're not looking at transporters. Frankly, we didn't think of that, and that probably is something that we could have looked at. But we are looking at gut barrier function, and we're looking at the microbiome associated with the epithelium as well as in the digestion and so on. But yeah, that's one thing we're not looking at. But your comment about using cannula in order to partition our study into different segments of the intestinal tract is bang on.